Okay, so we're in the second half of 2.4. I split it up so that you can focus one day on the definition of continuity. That was yesterday, now you can start using it on a regular basis. Today, not very much. What I tell you today allows you to assume functions are continuous. Okay, so can you name some functions that you know are continuous? Okay. Okay. Others. Think back to last year, what graphs did we do? What functions did we work with? Exponentials. What else? Okay, we got parabolas up here. Yeah. So you're thinking parent graphs, what types of functions did we address over that? These are exponentials, right? These are polynomials. So what are the polynomials out there? Right? Any of those? All those are all continuous, right? If you look at a graph, it's a good curve. A rational function always continuous. No. Okay, so rational functions may not be continuous. Are there any others on this list that you can think of? Yeah, that would be in the same line as these, right? Any linear function, okay, which is really just a polynomial. There are a couple more. Think music. Are those continuous? What else? What was the inverse of exponentials? Logs. Those are continuous on their domain. What's the domain of a log? You can't have negatives or zeros in logs. You say they're continuous on their domain. There's one more. Roots. What's the domain of a square root function? Yeah. Make sure you include the bracket at 0. The 0 is okay in square root. Right? Okay, so if you see any of these functions, you can automatically assume that it's continuous. You don't have to use the definition every time. Okay, so now I'm giving you permission to say x squared is continuous. Right? I don't need the definition right up every time. That, yeah. Somebody has shown these are all continuous. You don't have to do it too. Okay, so you can just assume they are. Discontinuities come with, a lot of times you're gonna either get a rational or a piecewise function. Can you think of any others that might be discontinuous at times? And this is just a question off the top of my head. Where do those come from? Rational function. Okay, so we've covered that. There'll be an infinite discontinuity, right?
Yeah.
All right. I think our list is pretty good. Okay. So think about in that manner. Ooh, I almost. Function operations. So if I know that f is continuous and g is continuous, if I add them together, what happens? Are they still continuous? Is the new function still continuous? What do you think? Intuitively? Yeah. Yeah, so f of x plus g of x and minus, so these are still continuous. How else do we combine functions? Multiply? Yeah. That works. Still continuous. So x times sine x, you can say it's continuous because we know that each of those are. You know what C is? The constant. It's just a number. So you can multiply a function by any number. It's still going to be continuous. Like 2x squared. What about this one? Okay, what can g of x not equal? 0. Now we're good. What about this? Yeah, it is, actually. So compositions are continuous as well. What about inverse? Remember that notation? Still continuous? Yeah, yeah. So all these, you're still doing these operations, they're all still continuous. Okay? So we're just kind of adding to your toolbox. Or when we really analyze the rational functions and piecewise functions. Okay. All right. Any questions? That's it.
Wait, so I minus one or?
Yeah, superscript, as we call it.
So they have a.
Well, clear. It's up to the, at the top of the room.
Okay.
We can also do subscript.
Okay.
This is super. So normally you'd put a letter here, but it's super is above.
That was awesome.
So you dare tell anybody I did that? Good, we're good. It is online, so there's no questions. When I run for president, right? That's not bad.
If you have a discontinuous, I can continue this, or you can discontinue.
90%, 10%.
Probably.
Positive.
Depending on, I would imagine so, yeah, like if you're thinking graph. Because all you're doing is like adding the y values. Just gonna add them down. Right. You gotta write a lot here. I choose these problems very specifically. Okay.
That 57.
Either.
Here you go. You've got 25 minutes to work on it, so. Let me know if you have any questions.
What is this?
Today's
due?
Thursday.
Yeah.
We will score it tomorrow, and you have a quiz.
What?
You have a quiz tomorrow.
Does that mean no homework?
Do I hate you? Yeah.
So we have no homework
Next
tomorrow?
question. No, I'm not gonna give you homework tomorrow.
Oh,
Keep
dude,
in
I
mind,
could give you $1.
the quiz is 3.1 to 3.
Oh, you're still mad.
2.1 to 2.4.
I don't know.
It's limits and continuity. Graphical, numeric, and then probably a continuity question on there.
That's 51.
Keep in mind, tomorrow's our last day together for 2 weeks. Okay, so we're gonna prep for that. Hopefully, we'll be okay. I think you guys will be okay.
Here, you just do it.
I'm worried about one class, it's not this one. I freak out for this class. No, I'm good. There's just 32 of them. They're loud. Obnoxious. Take one, I've got one. One more.
They're all fine, so it doesn't- No, they're fine. So- Oh.
Are we all a little clear on the definition of continuity now? I'll write it out.
Wait, Mr. Arthur, you got that?
I'm just gonna come out and look at it.